constant rate of change. Here's where we start to take the algebra that we've been working on, actually pre-algebra that we've been working on, and putting it into practice and doing something with it. So for constant rate of change, this is something that we've worked on in years past. We've called it rates and ratios, and we've called it actually constant rate of change previously too. But here's our baby step into turning the algebra into something useful. So with constant rate of change, the thing that we're looking for is linear relationships. And when we have a constant rate of change, when we have a CROC, a constant rate of change, that indicates that the relationship we have is linear. Now I could say linear or I could show you linear, so let's do both of those. Linear is any equation that when we graph it, it would graph as a straight line, and that straight line goes off into infinity, both going forward and backward, whether it's increasing or decreasing. So I'm going to put two relationships up here. Let's decide which one's linear and which one's not linear. So if I put that on there, and let's put this one on here. Now when you look at those two, which one's linear? Well, you can tell. It's pretty simple, right? The one that makes a straight line. If we were to draw that line, there's a straight line right there. This one is not linear. There's no way that we could get a straight line out of those data points. So that's where our constant rate of change comes in. Because this has a constant rate of change, it's going to form a linear relationship. This does not have a constant rate of change, no linear relationship. How do we figure out if there's a constant rate of change or not? We have to set up a table, and that table has two sets of values. Now for today, I'm just going to say this is our x and this is our y, and just remember that that is the case. And in the future, what you'll start to see is that x is an input and y is an output, but that's just foreshadowing. Don't worry about that yet. All we're checking for is a constant rate of change right now. So if we're looking for a constant rate of change, let's see how the points change. How do these x's change? So I'm going to put delta y here, that's the change of x. Then I'm going to put these carets on the side, and those carets are going to tell me how that x changes. So here I'm going from 5 to 10, so that's plus 5. 10 to 15, that's plus 5. 15 to 20, that's plus 5. We put my carets on this side. There's my one I'm missing. And the change of y, delta y. So now I've got 95 to 90, that's negative 5. 90 to 86, that's negative 4. 86 to 82, that's negative 4. Now we're checking for a constant rate of change, so what we're going to do is we're going to write ratios for the rates of change. We're always going to write them with x on the denominator, y on the numerator. So I've got negative 5 and positive 5, so my first ratio is negative 5 to positive 5. I've got negative 4 to positive 5, negative 4, positive 5, negative 4 to positive 5, negative 4 to positive 5. Now here's where that word constant matters. Do we have a constant rate of change? No, we don't. If we had a constant rate of change, every single one of these would have been the exact same ratio. Now we're given the data in a graph, and we're still checking for a constant rate of change. So how are we going to do that here? We're going to have to set up a table so that we can put our x's and our y's into that table. So over here on the side, I'm just going to make a little t-chart. Here's my x, here's my y. And I'm going to take the ordered pairs that I have in here. So this is 8 and 80. So if I put this in parentheses, 8, 80. I'm going to put over here 8 and 80. Here is 16 and 60. 16 and 60. This one is 24, that's my x value here, and 40, comma in between, 24, comma 40. Now we'll put the carets in, and the carets will tell us what our rates of changes are for our x's and our y's. So this one is plus 8, let me write delta x here. So as 8 changes, it's positive 8, positive 8. Here we've got negative 20 and negative 20. That is my delta y, how y is changing. Now let's write them as the ratios that they are. So this is negative 20 over 8. This one is negative 20 over 8. And yes, that means yes, we have a constant rate of change. And that's borne out by comparing the change of y over the change of x. What we've seen so far is how to find the constant rate of change. And the constant rate of change, if we have one, determines that we have a linear relationship. So let's do that first with this table right here. Let's check for a constant rate of change. My caret goes in plus 5, my caret goes in plus 5, that's my change of x. Then my change of y is plus 6, and then I check my ratios here, 6 to 5, 6 to 5. So what we've determined about this table is that we have a linear relationship. But there's only one of those, linear relationship, okay? The next step, though, is let's check to see if it's a proportional linear relationship. So proportional linear relationship is a relationship that if we were to graph it, it will go through the origin. So a proportional linear relationship compares two different numbers, where originally what we're checking for constant rate of change is we're comparing the ratio of the rates of change and checking to see if they're the same. Great. Now how do we check for proportionality? Proportionality gets checked by just doing the ratio of y's to x's. So in that, we look at this and say, let's get purple. Purple will be good for this. Here I've got y is 6 and x is 5. So there's my ratio of y to x. So let me write that as y over x. Here I've got 12 over 10. 12 over 10 simplifies to 6 over 5. 18 over 15, 18 over 15. If I divide both of those, both the numerator and the denominator by 3, I get 6 over 5. Now, because we have this constant, should I say constant? Because we have a constant ratio between the y's and the x's, what we've also found is that this table is proportional. One of the tricks to seeing this too is like, could you move the table back to 0, 0? Here we're increasing by 5s, increasing by 6s. So if I was to take away 5, we would have 0 chairs. If I were to take away the corresponding 6, we would need 0 cans of paint. So that's kind of like the back engineering way to see this. You could just walk it back to 0, 0. If it hits 0, 0, it's proportional. If it doesn't hit 0, 0, not proportional. Or we check the constant ratio of y's to x's. 6 to 5, 6 to 5, 6 to 5, proportional. One last one, so we're checking for whether or not it's linear and whether or not it's proportional. Linear will come if it's a constant rate of change. Proportional will come if it has a constant ratio between the x's and y's. So let's make our t-chart first and determine whether or not it's linear. So I've got, let's make sure we mark this, Mr. Romanovich, x and y. So I'm at 0, 4,000. I'm at 2, 3,000. And I'm at 6, 2,000. So we're checking the rates of change and their proportionality here. Here I'm at plus 2. Here I'm at plus 4. Okay? Now what that gives me is my change of x. Now let's check my change of y. Here I am at minus 1,000 and minus 1,000. Now the ratios are what matters. Let's determine if it's a linear equation or not. Now here I've got y over x, negative 1,000 over 2. And here I've got negative 1,000 over 4. We don't have a constant rate of change. Now because we don't have a constant rate of change, this is non-linear. So we don't even have to check for proportionality because it can't be proportional when it's non-linear. Let's go to the vocab. We got a bunch today. Okay, so what we got is a linear relationship. That is formed when we have a linear equation, right? And that linear equation will graph as a straight line. Then we also have our constant rate of change. And our constant rate of change is found by comparing the change of y over the change of x. And it needs to be, as we know, constant. And what we also determined was proportionality. Proportionality. And the proportionality then is determined by the actual change of y and the change, or the comparison of y to x. So as we look at it, does every y divided by x make the same ratio? Okay, good luck.